Welcome back to Tech Pulse, the show where we break down the biggest stories in science and technology and make them make sense. I'm Zaper, your guide through today's cosmic headlines.
And I'm Puck, here to ask the questions you're probably already thinking. And hey, before we jump in, don't forget to hit that subscribe button. It helps us keep bringing you these deep dives every week.
All right, let's dive in. Enceladus organic molecules may not come from its ocean.
Wait, hold up. That's a twist, because for years I thought the whole excitement was that Saturn's moon Enceladus might have life in its ocean.
Exactly, and that's been the big pitch since NASA's Cassini mission spotted those dramatic water plumes back in 2005. But new research says maybe not so fast.
Okay, pause. Let's make sure everyone's on the same page. First, Enceladus.
Right, so Enceladus is one of Saturn's smaller moons. It's icy, bright white, about 500 kilometers across, roughly the size of England. And it's famous for blasting huge water plumes into space.
And those plumes, scientists thought they were coming from cracks in the ice, which connect all the way down to an underground ocean, right?
Yes, those cracks are even nicknamed tiger stripes. They're basically vents. Cassini flew right through those plumes, and the instruments detected organic molecules.
And by organic, we don't mean whole foods. We mean carbon-based chemistry, the kind that could, maybe, possibly, eventually lead to life.
Exactly. So for the past 20 years, the narrative has been Enceladus's ocean might be habitable.
And this new research is throwing cold water on that. Pun very much intended.
The study was presented just days ago at the EPSC-DPS2025 Joint Meeting in Helsinki. Dr. Grace Richards from the Italian National Institute for Astrophysics and Planetary Science led the team.
And what they did was basically recreate Enceladus in the lab?
Pretty much. They took ice mixtures, water, carbon dioxide, methane, ammonia, froze them down to minus 200 degrees Celsius, and then blasted them with ions to mimic Saturn's radiation environment.
Sounds like a sci-fi cooking show. Like, next up, let's add a sprinkle of cosmic rays.
And out of that experiment, they got all sorts of molecules: carbon monoxide, cyanate, ammonium, and even precursors to amino acids.
Wait, amino acids, as in the building blocks of proteins.
Yep, which means these organics could form just from surface radiation chemistry, no deep ocean needed.
So this doesn't mean there's no chance of life in the ocean, right?
Correct. It just means we can't assume the molecules are proof of an ocean biosphere. They could be created right at the surface.
That's like thinking you've found coffee beans from some exotic rainforest, but it turns out they grew in your backyard all along.
Perfect analogy. And this complicates things for future missions.
Because if we send a probe, scoop up a sample from a plume and go, aha, organic molecules, we might be celebrating too early.
Exactly. We need to tell the difference between surface chemistry organics and deep ocean organics. That's going to require more advanced instruments, probably as a part of ESA's upcoming Voyage 2050 program.
Man, the universe is always like, not so fast, humans.
True, but it's also a reminder that science is self-correcting. Every discovery adds nuance.
And keeps us humble. I mean, just imagine, 2005, Cassini spots those plumes, and suddenly astrobiologists are like, life, life. Fast forward to 2025, and it's, well, maybe not, but also maybe yes.
Yeah, it's the ultimate cosmic, it's complicated. So here's the bottom line. These findings don't rule out life in Enceladus's ocean, but they do mean we need to be cautious about interpreting organics as evidence.
Numbers-wise, it's worth noting, Cassini cost about $3.26 billion. Future missions could cost even more. So if we're going to invest that kind of money, we need instruments that can tell surface chemistry apart from deep ocean chemistry.
Exactly. Otherwise, we risk misreading the data.
And honestly, I kind of love that we're debating molecules on an ice ball 500 million miles away. Like, what a time to be alive.
Couldn't agree more.
All right, that's our deep dive into Enceladus and its maybe, maybe not ocean organics.
If you enjoyed this breakdown, make sure to like, comment, and subscribe. We've got more stories like this. Cutting-edge, game-changing science coming every week.
And hey, drop a comment. Do you think Enceladus has life hiding in that ocean, or are we just seeing chemistry tricks on the surface?
Either way, the mystery continues. Thanks for listening to Tech Pulse.
Catch you next time.